Hello and welcome to the channel. This is Soham and today we are going to implement one of the most famous game called the Game of Life. For those of you who do not know about the game, let me explain it in a short way. So the game was invented by the famous British mathematician John Conway in 1970 to explain the unpredictable cellular automata. And it was later experts were able to prove that with proper initial configuration, it can satisfy von Neumann's universal constructions. And the game was so famous and so powerful that it also featured in Stephen Hawking's The Grand Design as a means to explain our own universe. On a high level, you can think that by this we can simulate the rule of the universe, the rule that controls the universe, that controls the life in the universe. I will come to this very soon. Now let me come to the rule of the games. So the game is basically a zero-player game, which means its evolution or its progression is determined completely by its initial state, requiring no further input. There are three main rules for the games to evolve, or the three rules which decides the next state of the game. Number one. So you can think this game as a board of chess where certain squares are there, and we will denote a square, a filled-in square, to be a live cell and an empty square to be a dead cell. So rule number one, a filled-in square is alive and an empty square is dead. That's our denotation. Rule number two, that's the most important one. If a living square or has two or three living neighbor, it continues to live in the next state. Rule number three, if a dead square or an empty square has exactly three live neighbor or three filled-in neighbor, it comes alive in the next step. For every other scenarios, the square die or remains dead on the next state. So this is the rule. I'll provide the rule in the description box so that you can have it in front of you when you are watching this video. It will be easier for you to relate this to the program that we are going to implement. So let me now jump into the code and let's see how we can do this. So as I have said, the first statement, should be the import statement for all the module that we are going to need here. So import. So I would require random module here. I would require time here, and I would require copy. Now, as I said that it's a zero-player game, so at first we need to have our initial state. So let me build or let me implement that part of the code first so that my initial state would be configured. So for that I will use two variables called width and height. So width is nothing but you can imagine as the width of the chessboard. So how many columns would be there? So let's say my width would be 30 and height is you can think it of how many number of cells would be there in a column. So let's say height is 20. So 20 squares will be there in a particular column. So height is equal to 20. So that's it for now. If we need something, we can add a variable later. Yeah, so now this is the dimensional value, but now how to store that two-dimensional data? So for now, I'll use the list data type. I will use lists inside lists. So let me name it as next cells. You will understand the naming rules later, why I'm calling it as next cells. So next cells, let it be an empty list for now. So when I'm saying that it would be a list of lists, it means that you can think of every column as a list. Here I am going to have 30 columns, so I will have 30 lists inside these next cells, and every list inside these next cells will contain 20 values because the height is 20. Okay, now we need to populate the next cells. That would be our initial configuration. So for that we have to have a loop. So what I'll do is I'm going to pick up one list, populate it, and then we'll pick up another. So let me open a for loop. So I have 60 lists, I have 30 lists to populate. So my outer loop should be loop through 60 times, 30 times, my mistake. So let me loop it over on width. So for x in range width, inside it I have to populate each and every column. So I have to iterate over the height of the column so that I can exactly loop over the number of cells inside a column. So similarly I would say for y in range height. Now here comes a population part. Okay, I will keep the population as much dynamic as possible. So let me use the random function here. So let me open if random. So 0 to 1. So that function would produce either 0 or 1 is equals to let's say 0. So if it returns 0, then I would treat it as a live cell, and for live cell I'm going to denote it as hash. So okay, now to store hash I have to create a column. So let me open a variable here called as column, which is also an empty list that is going to be inside next cells. So that's the thing. So if it is 0, if the random function returns 0, I made a typo here. If it returns 0, then I would assign hash here. So column dot append on hash. So it would be a live cell. Else, if it returns 1, I would put a space, let's say, denotes a dead cell. Okay, so that's it for populating my column. So once I'm done with this loop, which means that I have populated the column for the 20 values, because the height is 20 and I'm going to loop it over height. So once the population is done, then I would require to put the column inside next cells. So this step, just after coming out from the inner for loop, my statement should be an assignment statement. which would assign next cells. I can use this one, next cells to print column. So I'm going to append the entire list named as column into that next cells, which is itself a list. So it will contain a number of lists inside it. So that's completes my loop for initial configuration. Now for let us just print this configuration so that we can see how it looks like, how the configuration looks like. Let me print it. So print, or we need to basically look through it and then print, because we can't print it in one go. If I print it in one go, it will be like a list of lists. The visualization would be not understandable much on this perspective. So let me open a loop. So what I'll do is I'll try to print it in a way so that it will look like a two-dimensional matrix. So here so to print it, what we need to do is, let's say the next cells, this list data type next cell contains 5 lists inside it. So we have to print, or we have to loop through each of the lists and have to pick up the first element. Then we need to move out to the immediate next list and pick up the first element, and we need to do it so that we can have our first row in the two-dimensional matrix. So in this case, we have to loop through first with the height, because we have, see, let me open the loop, then it will be easier for you to understand. So for y in range height, then for x in range width. Okay, so now if you want to visualize the loop here, so the first loop is on height. So basically here the outer loop will loop through each of the row in a two-dimensional matrix, you can imagine. So basically, and the inner loop will loop through 30 times for the width. Why? Because we are going to, we have 30 columns inside it. So to print it as a two-dimensional matrix, we have to pick up the first value from each of the columns. So we have to loop it over 30 times. So let me print it here. Print next cells now. Here I have to place x, because that will denote my first list in the next cells, then y, which is the first element of the first list. So this x will denote, or x points to the first list and y points to the first element of the first list. Okay, now as I told, I have to print it side by side so that it would look like a two-dimensional matrix. So instead of placing a new line after the print, which comes by default, I am explicitly mentioning to place a blank, or you can say, a null. So once this is done, if we want, we can print a new line here. Just print statement would do, just so that we can have a gap after each and every row in the two-dimensional matrix. Okay, so that's it for now. Let us print this. Let me run it and let's see if I have done any syntactical mistakes or something. Let me maximize it. Yeah. So it is saying that, okay, random module is not callable because I have to use randint function. Okay, so let me run it again. It is taking a bit of time. Yeah, it has come. So let me maximize it. So this is it. This is the initial configuration. So every hash represents a live cell and every blank in between represents the dead cell. If we want, we can omit the gap between each and every line, and let us do that and see how it looks. I think the yeah, so if let me omit this one, or let me comment it and let me run it so that we can see how it looks like. Then we will decide whether we'll keep it or we'll revert it. Okay. Yeah. So why this has happened? See, if you see here, as I have commented the new line, so it is printing side by side, which is not required. It is not, in a two-dimensional matrix sense. So we have to keep the print statement here so that for every column or for every list inside the list would be like a two-dimensional matrix. So let me print it again and confirm that the way we want. Yeah, so this is fine. This is almost resembles like a two-dimensional matrix. So every row corresponds to the lists inside a list. So this is this is list number 0, this is list number 2, this is list number 3, like this. So yeah, okay. So let me delete this one for now. So that's it. So we have configured our initial configuration. Now we are going to implement the actual game, and as I say that no player input is required. It's a zero-player game and it will evaluate itself. So we have to have a while loop or forever while loop. So let me give, I'm not giving any conditions for the while loop, and I am making the while so that it is become always true. So while true. So why I'm keeping this print statement here? Because every time I have to print the status so that we can understand evolution of the game. So this print statement is required for each and every iteration. So I'm keeping this inside the while loop. So this is for printing the statement. Okay. So now let us do one thing. As this is the initial configuration which we called as next cells. Let us first, before printing, uh, add the entire thing in another variable, because we will have to manipulate on that uh, variable. So after manipulation or after calculating the next state, we have to have some placeholder to store that state. Otherwise we will manipulate on the same variable, and we will print the same variable, the code won't work. So in the first statement, let us do one thing. Let us assign this next cell in a variable called current cell, and we will work on it. So current cell is equals to the next cell. Now here comes one small trick. As this is the list data type, if I do this simple assignment operation, instead of storing the values of next cells into the current cell, it will pass the reference of next cells to current cells. So if or whenever we are going to modify something in the next cell, the same would be reflected in current cell. So that's why we have imported the copy module here. So there is a function called deep copy inside the copy module, which actually stores the value instead of the reference. So, and this is the syntax. So that's how we are copying the values of next cells into the current cell. Okay, and so for printing, we will print the contents of current cell. Done. Okay. So once we are done with it, now we will need to calculate the surroundings of a current cell. So as the rule suggests that living of a cell or dying of a cell depends on its surroundings, or to be more specific, depends on the number of living cells around a cell. So we will calculate for each cell the number of live cells around it. Okay, so for that we again have to open a loop. So let's open up a loop for x and width, because we have to loop over 30 columns or 30 lists that the main lists have. So for x in range of width, because only width will not work. And then we will loop through each and every value of a particular list, or rather column. So for y in range height, okay. Now let us calculate the coordinates. So for a particular cells, we may have left coordinate, which should be equals to, see, a left coordinate means, if you visualize on list as a column, just transpose it. So it basically means like if X denotes uh, your list, so and you are visualizing it as a two-dimensional matrix like the way we printed it, so it should be the uh, lists just before it. So X minus 1 should be the one that is residing at the current cell's left side. So this X minus 1 should be our left coordinate. Now here comes one tricky thing. For the first loop, X and Y always be 0 and 0 minus 1 would be minus 1, and we do not have any values at minus 1, right? So we have to have something so that 0 minus 1 wouldn't give us minus 1, rather it should be like a circle, like when I'm subtracting, or I'm trying to calculate the left coordinate of the values that is there at 0 comma 0 position. It should give me the last position of that. Like for 0 0, if I do a minus 1, it should give me like minus 29 comma 0, right? So that's Python has a very interesting way to do that. So if you do a modular division on as it is a you know as we are traversing through height, so this shouldn't be greater than the height. So if we do a modular division by width here, because width denotes, I mean X denotes width, you will get your desired result. Now if you are not able to understand this logic, I will put a comment, I'll put a link from the Stack Overflow which very clearly explains how this modular division operation is a bit different from other programming language, and if you get a look at it, you will get to know why I'm using it here. I'm not going to explain it in this scope. Okay, so in this way I'm going to calculate the right coordinate, which is obviously this one, x plus 1, and in the same way. So for now you can take it as my left coordinate would be anything between 0 to 30, but no negative numbers would be there. So 0 minus 1 would not, I would not get minus 1 here. So that's the motive that I'm using the modular division operation here. In the same way, that's left coordinate, right coordinate, and upper coordinate. That should be y. So my y minus 1 should be the value above the current cell. So here I would do with height, because I don't want any value except 0 to 20, because my height here is 20 and that is the variable. So upper coordinate is done. Now lower coordinate. Okay, so I've calculated my left, right, upper and lower coordinate. Now I'm going to calculate the number of living neighbors for my current cell or current value. So now let me write down the conditions with a if and else state. So if the first condition, I'd see my left coordinate, that whether it's a living cell or a dead cell. So if so here if you see here, we have initialize this next cells with the current cell. So if our current cell left coordinate that should be right, so that here we are checking just exact left side of our current cell is equals to hash. So my motive here is to calculate the number of living cells surrounding my current cells. So I'll start with my immediate left position. Okay, so if this condition satisfies, then I'm having the I have to store that value somewhere. So let me open a loop here, a variable here, like living cell, and initialize is as 0, and here I'm going to increment it by 1. So living cell is equals to living cell plus 1. Okay, so I've checked this condition. Now I will check for my right coordinate. So if current cell, now how to check my right coordinate? It's very simple. Just put the right coordinate here so that it will calculate the x plus 1. So the next list and y should be same, is equals to same condition. If hash, then my living cell would be living cell plus 1. Okay, so I have checked my left and right. So now I will check upper and lower. So if current cell, now here to check the upper and lower, which means that inside a cell, inside a list, so there is a list of lists, so just consider the first list. So the upper of the current value, which means the immediate left value of the current one inside that particular list. So basically, if the current value is of third position of a particular list, that upper value should be second position and the lower value should be fourth position. So x would remain same and my y coordinates value would be the upper coordinate. Let's say I'm calculating the upper one here. So upper coordinate is here. If this is a hash, then also I'll count the living cell. In similar way, I will calculate or check the lower coordinate. Lower coordinate is equals to hash. Then also leading count will get increased by 1. Okay, so I have checked my left, right, upper and lower. So now I have to check my upper left, lower left, upper right and lower right. So for that, what I'll do is if currency, so my x coordinate would be say left coordinate. Okay, and y would be the upper one, so that I'm calculating my upper left. If it is equals to hash, so this colon here, that living potential one. Let me copy that part because I'm going to need it for 3 more times. Okay, so I have checked the upper left. Now I'll check for the upper right. So for upper right, that should x should become the right coordinate, or x should denote the right coordinate, and that and this should be same. The y should denote the upper coordinate. Yeah. If it is hash, then I'm going to count this. So I'm done with the upper left and right. Now I am going to calculate lower left and right. So for lower one, right should be the same. So that should be the lower coordinate. So that would calculate the lower right. So if it is a hash, then I'm going to count it as 1. I'm going to increment it as 1. Then in a similar way, if so lower right has been calculated, now I have to calculate the lower left. So that should be the left line. So yeah, so left coordinate. So in this way, we have calculated all the 8 positions or 8 surrounding positions that we are going to consider. Okay, so we have calculated the number of living cells for a particular cell. Now let us implement a rule here. So if the current cell if the current cell, which which is simply this one, as it looks true, is equals to a living cell, means a hash, and it has exactly 2 or 3 living cells surrounding it. How to write this in a coding language? Oops. Let me copy this variable. Yeah. So if this is equal to 2 or this is equal to 3, okay, then my next cells, so here I'm calculating and appending the position in the next cell, so that is going to represent my next state. So my next cells xy should be a live one because it is satisfying the condition, so it should be hash, right? Else if, sorry, else if my current cell is hash, or rather, let's say my current cell is a dead one, because I'm going to calculate the condition for which a cell can be alive. Okay, so because there are only 2 conditions on which a cell can become alive or remains alive, so we should be calculating that. So if it is dead and it has exactly 3 living neighbors, so this is equals to 3, so it is going to be alive, right? So if this is the case, I have done some indentation mistake, so let me correct this. Yeah. Let's say this, then look. So all other condition except these 2 condition makes a cell as dead one. So simply write else next cells xy is equal to this. Okay, that's a dead one. Now I've done calculating each of the value in a column, because this is the statements inside the while or the column loops or the height loop. So once this is done, one loop is done, then it will again calculate for the next lists or the next column, you can say. So once this is done, we can add one thing, like this is done and the next cells has been prepared here, so then again it will be here and the next cell will be copied in the current cell and it is going to print that one. So just to stop flickering, we can add one thing here when the loop is completed, just do a sleep command so that it would not flicker and we will be able to understand the state changes. So time.sleep, it's a function just to pause the execution for 1 second. Okay, so I think we're done with the programming, so let us execute it and see whether it's working or not, or any syntactical mistake is there. So I'm hitting Control F5. Let's see. Okay, so it is giving some error. It says that index error, listen out of range. Okay, line 53. Let's go to line 53. Here is the line 50. Okay, this is a syntactical error. So typo rather. Let me delete this one and now print it. Okay. Let it execute again. Yep. Something is coming up. Okay, so it is running, but we are not able to differentiate between each and every step. So let me stop this one, and we have to put in some new lines after each and every output of each and every step. So here we are printing the state of each step. So instead of printing this, let me print some 3 or 4 new lines, say. So this is, I'm going to print 3 new lines. Okay, just to differentiate between each and every steps. Okay, so let me delete this one and run it again. Maximize it. No, this is still not working. This is not the way we want it to work. So let me hit Shift F5 and close it and analyze it closely. Okay. So there is something missing in the print statement, that is for sure. So here, if we analyze it in a closed way, here I'm printing it. Printing this statement is basically printing row in the two-dimensional matrix, you can say. So we have to do something here. Okay, I got it. So yes, so if we see the flow, so as the width here is 30, so it will print 30 values here. Once done, it is currently printing 3 new lines, which I don't want at all. So let us remove the print statement from here. Okay, so here, after printing the entire row, it will again go back here and then it will print the next line. So it's better to have just a print statement here, so that it will act as a row separator, and once done, once a particular state has been printed here, we should have a new line after that. So it is better if we have a print statement at the very top of it. Okay, let us run it and see my assumption is correct or not. Let me maximize it. No. Okay, it's bringing something. Okay, I think this is the thing we want. So just see the beauty of it. Like, this is one of the state of the game. Every pass is going through, and you see the movement of the cells. So each and every pass will show you different configuration of the board. So that's how you can relate, just in an imaginary way. You can relate our universe, like when we are setting the rule that when a living cell has exactly 2 or 3 living cells around it, it becomes alive, which means that for a life to be live on this universe, it have to be surrounded by some lives. And if it is surrounded by overpopulation, or so many lives, when so many lives are there in a place, that is bound to lose from our art. So like that you can relate this one. So this is one of the most powerful game which can mimic various automation thing. Like it can mimic the CPU usage. It can relate with the rule of universe, like von Neumann universal constructors, etc. So this is the beauty of this game, and the program is very simple. But yes, a video is going to be a very long video, because I wanted to show how actually a programmer implement this, and how the programmer faces difficulties while implementing. So yeah, so that's it. So if you have learned something, or if you enjoyed the video, just hit a like, to subscribe, and share it with your friends. So bye for now.